Hello Hornets, welcome and thank you for joining me today. Today we're going to be taking a look at approximations of areas under curves. We're going to be looking at the upper sums this time of circumscribed rectangles. So upper sums of circumscribed rectangles. We're going to be doing numbers 5 and 7 in this video. So if you take a moment, please do your screenshot. Alrighty, let's go ahead and begin. Just as we did before, I'm going to go ahead and I'm going to graph it on a separate piece of paper, and I'm going to make sure that I list the important information. That y is negative x plus 3. We are working on the interval negative 6 to 2, and we want 4 rectangles. Now once again, this is simply a linear equation. I'm going to draw my linear equation. I know that at 2 I have 1, so I'm going to make sure I have 2 is 1. That's a little bit too low. 2 is 1, and 6 is going to be negative 6 will be 9, I believe. So let's put 9 up here. I'm going to go ahead and I'm going to draw my line segment. And I now need to get 3 intervals. So negative 4, negative 2, 0, 2. And that's not negative 2, that's a positive 2. Alrighty, so we're now ready. We're going to go ahead and we're just going to put our vertical lines in at each of these points. Going to have to find those heights, and the only one I know right now is the 2, 1 and the negative 6, 9. We do know that this one is 0, 3, and then we have negative 2, 5 and negative 4, 7. Now when we're doing our circumscribed, we want to make sure that our rectangle is now above. So we're looking like this. See, I'm creating the rectangles and I'm making sure that each rectangle is outside of the curve. Each of these lengths is now 2. So I have 2 times the first height, which is 9, plus 2 times the second height, which is 7, plus 2 times the third height is 5, plus 2 times the fourth height is 3. And when I add them all up, I get 48. So 48 is my answer. Then we go to number 7. Number 7 was y equals x squared over 2 minus x plus 2 on the interval negative 3 to 5. So we are going to have some decimals there. And we're looking at n equaling 4. I'm going to go ahead and I'm going to set up my graph. Close enough. And we are going from, there's 1, and we're going from negative 3 to 5, and so I want to make sure that I break this up. And I want lengths of 2 since I've got a total of 8. Oops. Try that again. And I'm going to move my 3 over a little bit. There we go. Negative 1. That'll have to work. It's not the best, but it will work. So here's my negative 3, here's negative 1, 1, 3, and 5. Alrighty, so we're now looking at 1 is giving me 1 3/2. And that is our vertex point, so just be aware of that. This one is -1 7/2. We have 3 7/2. -3 is 19/2. And 5 is 19/2 also. So we have 5 19/2. Each of these lengths is 2, and I want to over approximate. So 7/2, 7/2, that's actually a little lower. Okay, so my picture is really a bad picture because ultimately these two look like they are equal, okay, from these two segments. And I've got this one which is up here and then up here. And these two are equal. So keep in mind that my picture is pretty bad. So I've got a length of 2 times 19/2. And then I've got 2 of these, so I've got 4 of the 7/2. And then I've got 2 times 19/2 again. And when I add them all together, I get 52. So my answer is 52. And that is how we do the upper sums. Once again, the hardest part is just recognizing what's happening when you have this parabola like this and the 2 points on either side. Notice that the upper sum forces these 2 rectangles to go to that middle point. Okay? And you can't see that. There you go. Now you can see my picture. And this was our issue that we had. This was the 3/2, and then we had our 7/2, 7/2, 19/2, 19/2. Give us a picture that looks something like that. Okay? Alrighty, Hornets, that was our upper sum and the circumscribed rectangles. I hope that helped. If you liked it, please remember to click like. If you have suggestions, please give me helpful criticism, but try to be kind. Otherwise, thank you very much, Hornets. Cheers, be safe, take care. Bye-bye now.